Hey, Garrett.
Hey, Miss Sparks.
How are you, honey?
Tired?
Amen. Me too.
So I really needed help with like 28 through 41.
28 through 41. Okay. Let's see.
I
Uh,
also wanted to clarify a bit on some earlier problems, but I've already finished them. I just wanted to make sure I did them right.
okay. All right. Which ones?
Um,
Miss Wynn sent me some pictures, so I've got them on my phone. Let's see. But I have 1 through 10, it looks like. And let me see. Let me see. Uh, yeah. 11 through 26. And then I think that page. Oh yeah, all the ones that you had, because like one of them is like on a post-it note. Is that right?
yeah, but I wrote them to the side online.
Yeah, yeah, on the email you sent me. Thank you. Okay, what were the earlier ones, honey?
I just wanted to make sure that I was doing the second page correctly.
Okay, sweetie. Expand or condense?
Both.
Okay. Uh, all right. What did you get for, or do you want me to work it out like number 13 to see it worked out? Would that help, or do you want to just give me the answer?
I was kind of confused with 18.
Oh, 18. All right, let me take a look at that one. Condense each logarithm. Okay. Oh, that's a weird space in that one thing, so I can kind of see what you're talking about. Um, like how I changed my 3 to an 8. Okay, so I'm going to go ahead and write it out. Log 5 to the 11 plus
Are you
log.
trying to do something for me, Missy?
Oh, I'm so sorry, love. Thank you for the reminder. I did not share the screen with you. My apologies. Let me see. There she is. Okay. Log 11 and then log 5, 10 plus 5 log to the base 5 to the third. Okay, couple things going on. We know that the plus is going to be multiplication. So when we're condensing, we know we're going to go with log 5, right?
I put log 5 parentheses 11 times 10 times 3 to the fifth.
Oh my gosh, you're a genius. That's it. And it is a really big number.
I know that was like, there's no way I could calculate that because on our example page we did one like that, but it actually solved it all the way out. And I'm like, if I solve this all the way out, it's going to be super big.
Yeah, it's like 24,000 something. I can't remember. It was like, okay, so 11 times 10. Momo let me borrow a calculator because mine's dead. Equals, oops.
It's 26,730.
That's it. Yep. 26,730. I know that was probably scary to get that answer, wasn't it?
Yeah.
Actually, I remember there was a student that was doing it the other day, um, in my room. It was after school. I was cleaning up my room, and they thought it was wrong too. And I was like, no, that's really the right answer.
I wish this was all multiple choice so I could at least know that I was sort of doing something right.
Yeah, I know. It's always a relief when you see that, isn't it? You're like, whoo, my answer's there. That could either be a good thing or a bad thing.
Because sometimes they try to solve it the wrong way, ways that a beginner might do it, just so that they think they've got the right answer.
Yeah, just throw it in there to confuse you, right?
Yeah, it's like you're not helping any.
Yeah, no doubt. Well, what about 20? How'd you do on that one? Or do you want me to
20.
do 19 or 20? How'd you do?
I did not do 20.
Okay, you want to, well, let's do that one. Because it's weird when it's in a fraction like that. I don't know what tomorrow's test will be like, but when it's a fraction like that, don't freak. That's basically like it being multiplied by 1/3. So it could also be written like this. Okay, because that is a U, right?
Yeah.
Okay, because I'm trying to go from a picture off of a phone. So, all right, so then this 5 would go to here, and this 1/3 would go to there. All right. So you would have log W to the 5th. And it could either be written like this or more than likely like this. But those are the same thing. Does that make sense to you? That U raised to the 1/3 is the same thing as the cube root of U?
Yeah.
Okay. So if by chance tomorrow there's one of those weird fraction ones, because sometimes it'll be 1/2, sometimes it'll be 1/3, and if it's that, just remember that that's actually 1/3 multiplied by that. So it's the same, so that's the basic same thing.
Mm-hmm. And then I understand the whole like solve the equation ones where I have to like when they have the same base, and then I like just throw the what's in the parentheses and make a traditional algebra problem.
Yep, cool.
But I don't understand it when it comes to when it's the exponents are all weird.
Okay.
Yeah.
All right.
It's like 3 to the negative 2x equals 3 to the negative 2x. I don't know what they want.
Yeah. Is there one on there like that? That's that next page, isn't it?
That's 28.
20. Okay. All right. Okay, now on that one, this is cool because like number 28, they have the same base. 2x minus 3 equals 10 to the 3x. And when they have the same base, just like when it's like the logarithms, you just drop it. And it's 2x minus 3 equals 3x. And that's all there is to that one. And then solve it like a regular algebra problem.
Is it still an exponent, or will it just be its own number?
Oh, it's just going to be a number.
Oh.
So like to work this the rest of the way out, we'll subtract 2x from both sides. Oops, sorry about that. That's weird. We got negative 3 equals x. So negative 3 equals x.
So the same thing for the other one, right? Well, that would just be 1, right? Or would that be so confusing?
Oh, that one's weird. Yeah, 29. I think you're right when you say that about the 1 thing. Let's just work it all the way out just to prove it. Negative 2x equals negative 2x plus 2x plus 2x. We've got, actually, that's 0 equals 0. So basically, that's all real numbers. Number 29 is. Does that make sense? Whenever you have an algebra problem that's 0 equals 0 or 10 equals 10 or 0 equals 0 or whatever, that's all real numbers.
So just write all the numbers.
Yes, sir.
I just write all the numbers.
Yes, sir. Just write all real numbers for this one.
But what about 30 and 31 where the bases are different?
Okay, we're going to talk about those. That's a horse of a different color. All right. On that one, what you want to do, if at all possible, and and you want to see if you can get the bases to be the same. Like, what would we have to raise 5 to get to
This
6?
lot.
I am. Am I cutting out now? Can you hear me?
I think there's also a delay.
There's
You're
a
cutting in
delay.
and out.
Oh, huh. Let me see. I haven't changed anything.
Sometimes it's just a bad Wi-Fi connection.
Yeah. And I've never really done it. This is it better now? Can you hear me?
Yeah.
Oh, I hate that. I'll write as much as I possibly can to hopefully get where you can understand it. Is the writing delayed? Can you see the writing?
Yes, I can.
Okay. So you have to find what 5 would be raised to in order to get to 625.
Oh, and then you drop it and then you do the thingy.
Yes, sir. That's it.
Okay, that makes sense.
Good.
So what about for 31 where they both have an exponent but they're not the same base?
Okay. You're still gonna I can't really read that. Is that an R? Is the
It's
exponent?
100. It's 100 to the negative r equals 10 to the sixth.
Okay. Thank you. So I changed the 100 to be 10 raised to the second power because 10 squared is 100. So once again, I'm still trying to figure out what would give it the same base. And now I'm going to multiply 2 times negative r.
Wait, I'm confused.
Okay.
How did you get from negative r to 2 negative r?
Okay. See, 10 squared is equal to 100. So I'm changing 100 into something that has the same base. But I had to keep that there because that was the exponent. All I did was change this 100 to 10 squared. And then when it's a power to a power, you multiply. So if I had this before, you would just tell me, well, actually, that wouldn't work because that would be added. Um, this is the same thing, isn't it?
Yeah.
Do you see that?
Yeah, but why'd you put it over 2 then?
What do you
Are
mean?
you, are you dividing the 2 out of it?
Yes, at the bottom.
I
I'm
don't
just
know. I
solving it
don't
now.
like that. I always just kind of assume that it divides that thing out.
Oh, okay. So you don't actually show that step?
I just skip to r equals whatever that was
Oh,
divided.
okay. All right. I, I think I'm used to doing algebra 1 where I have to show every single step there. You know what I mean?
Uh-huh. Okay, I think I figured it out.
Does that make sense now?
Yeah, it does.
Okay.
I think 35 through 41 is all about E, and I forgot all about E.
She's easy to forget. Okay.
I'm
Uh
going to up with 32 and 34 first, though.
yeah, that's what I was going to say. We probably should work on those. This is that change of base stuff.
But they don't work out smoothly.
Yes, they don't. It's not pretty, but I'm going to show you how we'll make it a little prettier. But obviously, you see by the answer choices for the multiple choice on the first one, you're not going to get a pretty answer. So, and I'm trying to hold up my phone and erase because I'm trying to look at it at the same time to make sure I write it down right. 32. So we've got 10 to the 2x equals 23. Right?
Mm-hmm.
So that means log, and I'll write the base 10 just to write it out, but normally you wouldn't have to. Okay?
Mm-hmm.
Because if I change that to logarithm format, that's what if I would have said, "Oh, okay, now Garrett, write that in logarithm format." Like write this in logarithm format, you would have done this, right?
Yeah.
So so you could actually put this in your calculator. Just
What
do
is that?
log 23.
It's 1.361.
1.361 equals 2x, right?
Mm-hmm.
And now you're going to divide both sides by 2. And here's me showing all my steps again.
Oh, it's A.
There you go.
Okay, that makes more sense. I'm gonna try and do the next one.
Okay.
What would you do if it wasn't 10 as that number?
Great question. What I'm going to do on this one is I'm going to show you what you would do. On one of the steps, okay? Just in case. You would do this change of base. So you would do log 2 over log 10 and put it in the calculator that way. So like whatever this base was, like if that was a 6 or a 7 or a 2 or a 12 or whatever, that one goes on the bottom and this one goes on the top. So you just would type in your calculator log 2 divided by log whatever that other one is. But the big number goes on top and the little number goes on the bottom. And you just do it like a division problem.
By the way, for 34 is the answer 0.05017.
Is that the one we're working on? Hold on just one second.
For some reason, 33 isn't listed.
Right, right, right. What did you tell me for 34?
0.05017.
You got it.
Yay.
Yay. Good job. Okay,
Yeah,
now.
and the E thing.
Okay. Now, with the E thing, the first part of it is really, really easy because the like number 35, it's just like our, even though E has a value, you know,
Mm-hmm.
you treat it when it's in a situation like this, you treat it just like any other variable, even though it technically has a value. But here, you're just going to add the exponents.
So it's going to be e to the...
This is going to be weird because, yeah, it's going to be negative 2x plus 4. But here's another thing. I don't know if she's kind of expecting you guys, because this actually has a value. So maybe...
It's asking us to simplify them, not to solve them.
Okay. I wonder how simplified she wants it, though. You know, when y'all were doing those in class, what did she do?
I don't remember.
Okay.
I had a really bad problem with headaches and stuff.
Uh-huh. Oh, I'm sorry, honey.
It was really bad. I felt really bad, so I probably wasn't paying attention.
Oh, it's so hard to concentrate when you have a bad headache.
It was more than a headache. It was it had to do with my spine. I had strained it the wrong way, and so it was messing with my nerves, and it was literally making me super dizzy and have bad headaches, and I felt sick all over. It was awful.
Oh, wow. I hate that, Garrett. I'm so sorry. Are you feeling better now?
Yeah, I just had to try to improve my posture.
Oh, you and me both. I need to work on that. That was probably a word from the Lord. Hang on just a minute. I'm trying to see how far simplified she really wants them. Like if she wants it like that, or if she wants you to get the value of e to the fourth, you know, how.
Wouldn't that just be ln to the fourth?
That's when you're taking the logarithm of it. So let's see.
Is it 54.5981503?
The e to the fourth?
Yeah.
Oh, shh. That's my dog. Sorry. E to the fourth is yes, but I don't know if she she may just want it left like this.
I don't know what she wants, but this doesn't seem that bad.
Does it I'm going to text her and ask what she's looking for there.
What kind of dog do you have?
I have a greyhound, and then I have a cocker spaniel dachshund mix.
Oh, that's cute.
And the greyhound, a lot of times when I'm on math lab, if I don't put her in a different room, I need to get my kids to get her. She thinks I'm talking to her, and greyhounds are kind of notorious for talking. And so she thinks that she and I are having a conversation. Isn't that nice? I need to get my kids to come get her. Yeah, I think that she wants a value on that.
would that just be
Hang on.
That number to that?
To the negative 2x.
Yeah.
Um, yeah. Yeah. Let me. I'm gonna hold on just a minute. I'm gonna have to get my kids to come get the dog.
Okay.
I'm gonna put you on mute real quick.
Thank you.
I'm so sorry about that. Anyway, she just wants you to simplify it to this point. I got the kids to get my dogs, and I got that. She wants you just to simplify it to here. Don't worry about getting the value of e to the fourth.
Okay.
So just get it to where you know you're just like you obviously are combining your x and your negative 3x. Okay, so that's going to give you a negative 2x and then adding 4 to that.
All right. That makes sense.
All right. Now next. It looks like she sent me a picture of it, but I'm not sure if I'm reading it correctly, but it looks like the next one is the cube root of 8e 9x. Is that correct?
Yeah.
Okay, so what you're going to do is just take out all the cube roots. So you would actually do the cube root of 8 is 2. And believe it or not, when you're taking the cubed root of an exponent, you're actually dividing 3 into it. So that would just be e to the 3x.
I can't understand that one.
Okay.
Okay, the next section says to evaluate.
All right. Let me, once again, I'm trying to go to my phone so I can kind of see it. All
It
right.
says it's 2e to the negative 0.3.
2e to the negative 0.3. So basically all you're going to do really, Garrett, with this is you have your calculator with you, honey?
Yes.
All right. So what you're going to do is type in 2 and then second and then the LN button, which actually has a E to the X up above it.
Yeah.
And it should type in E, and then it should have a little box for you to put in your exponent there. And you're going to hit your negative sign that's down at the bottom next to your enter key, negative 0.3.
Is
And
it
then
1.48?
it's 1.48. Yes.
Okay, that's not that bad.
Yeah.
Same thing for the next one.
Yes, sir.
Is it 24.13?
Yes.
Okay, and then it says growth or decay.
Okay. Now, what you're going to do on those.
Just tell if it's growth or decay.
Yes. And let me show you how to do that. How you're going to have to isolate it, because that's going to help you on the graphing one too. Okay.
Does it have like, isn't it like if the exponents are negative or positive?
Yeah, that definitely has an indication, and you're absolutely right about that, because that's what's going to make it a fraction. So smart. 2.
So I'm guessing 39
Oh,
is
oops.
decay.
Shoot. Yes, because technically, and let me show you this piece, okay? So if you have f of x, because this is going to help you in the graphing one below as well, okay?
Mhm.
3, and then e, and then you see how that's negative x, right?
Yeah.
Or the opposite of x. What you really want to do is do this, break it out into a factor, okay? Because I mean, you can tell immediately if it's negative, it's going to be a decay. But I want you to know that you can break that out and just do e to the negative 1. And if you get a decimal, it's decay.
Okay.
All right. Does that make sense?
So I say, what do you mean if it's a decimal?
Like plug in second.
Because,
E,
oh, you mean like for 40, I put in e to the 4 and I got 54.5981.
you,
Does that mean it's decay or growth?
that means it's growth because it's not a decimal. Like I mean, it's a bigger, because what was it
The whole
again?
number, it's not like 0.59, it's 54.
Right. If you plug in e to the negative 1, it should be like 0.0 something, or point, what is it? Second e negative 1 equals. It equals, this equals 0.36. So it's less than 1. So that means it's decay.
Okay, I get it now.
Okay.
And
All
then
right.
there's the graph problems, last one.
Yeah. And so 39 was decay and 40 was growth.
Yeah.
And you get how to figure those, correct?
Yes.
Okay, cool. Is this all making more sense?
Yeah.
Praise God. All right, 41. Y equals, and just like I told you before, I would do this because then when you do your chart, you're going to be putting in values just for this part, because this is going to be a value itself. Does that make sense?
Mm-hmm.
So we've got
What?
2 times e to the negative 3 Hang on just a second. I'm writing something down. A second. This value right here is 0.04. I wonder how far out I should go. I'm going to go with 4 digits raised to that minus 1. So now we're going to stick in. If I stuck in a 0 for that x, that's always going to be 1, right?
Yeah.
Because anything raised to the 0 power is 1. So that's always a nice one to go with. And then if I stick in, oops, my bad. It's not going to be 1 here, though, is it? Because you're going to do 2 times 1, which is 2. Because what you're going to do now is just plug in all these numbers. So you have to raise this to, if I plug in a 0, 2 times 0 raised to the 0 power minus 1. And then so you'll calculate that, and that'll be one of your points. How many points does she want you to get?
I have no idea.
We're trying to think. For this, you probably need at least 3 or 4, I would think. It is 1. I was right. And then 2 times 0.498.
Just want to do -1 and 1.
Yeah, let's try that. Oh, wow. Big number. -1 is huge. Did you do it?
I understand the concept. Just plug in the number.
Okay, because I'm like, oh, it is huge. Let's see. That's negative 0.9004. So I don't know. Those are some wicked looking points there, you know?
I'm just going to do it by tens.
Oh, okay.
So that'd be 0, 1, which would be like right on the line.
Yes.
And then
What happens with 10?
And then -1.
That's That's that 3, 9. What? Oh, you're going to do the graphing by tens. I got you.
It should be right below the line for 40.
Oh, okay, there you go. How's it looking?
It's looking okay. I don't know how it's supposed to look, so. And then 1 would be right below, right above the line. So it's like it comes like from the top and then it goes all the way down. Like it comes like on a curve through the origin.
Okay.
Is that right?
Yeah, because it's an exponential graph.
So it's decay.
Yes. Good job. You're so smart. You're doing great.
Well, thank you so much for helping me get through this, especially so late.
Oh, hey, no problem. No, thanks for meeting with me late.
I guess I'll try to see if I can do that test good tomorrow.
You'll do great. You did good just now. You knew that it was decay. That was great. And breaking it down.
Anyway, I guess I'll see you next math lab.
Okay. All right.
Bye.
Um, bye-bye.